Hi guys, welcome back to my tutorial. So sorry I went on a break for some time and now I'm back, fully back for you. So today we'll be working on polarization identity, just a simple proof. If you're new to this channel, please I'd like you to before that you have to watch my videos to know how fine and how interesting it is. So after that you can then decide to subscribe, but trust me, I'm very sure you're going to want to subscribe and turn on the notification bell because I'll be posting more beautiful and interesting videos in mathematics. So now let's just work with this for now first. So today we're working on polarization identity. So as you can see, this is the proof here. This is the statement we want to prove. We have x comma y, they all belong to both belong to a real inner product space. So in short, this topic is under inner product space, so we're just taking a proof. So you can actually see a polarization identity not having the complex part that you have to prove. But for now, suppose we have this complex part and we have to prove all this. So how are you going to go about it? So the first thing is you have to understand what a norm is. So let's say you're asked to find norm of x. So it's just square root of inner product of x comma inner product of x. So this is it. But let's say you're asked to find this. So you don't have to look for the square roots anymore, right? You just have to have it to be x inner product of x comma x. So you get the same strategy. This is the only thing you need to prove, and then little knowledge under complex because we're proving under complex space. So right back to what we're proving. So I started without you guys and I feel no, I have to stop. I have to continue with you guys. I have to prove with you guys, so I won't just come here and then start to explain how I got it. So for the first part, I started from the right hand side, so you have to start from right hand side to go back to the left hand side. So if you're able to prove from right to left and you have this, then we're correct. So let's continue. All right, so for the first part, I'll take it one by one and then I'll add, subtract. So then I'm going to subtract, add and subtract. So let's take for the first part this part. I have x plus y, norm squared of x plus y. So I'll take it as x plus y comma x plus y, right? And I'll just let's say I want to open brackets, so I have x plus y, x plus y. Normally we have to just take this first one x, and then I have x plus y, and I take the second part plus y, x plus y, right? So the same thing here, just I'll be using inner product instead. So here I have x first, then this x plus y, then y, this x plus y, and I start to open the bracket. So here I have x comma x plus x, this x comma y, then y comma x plus this y comma y. I already know from what I gave you initially. It said if you have this is equal to this. So if I have norm squared of y is going to be what? Inner product of y comma y, right? So similarly, if I have this, I'll have this and then this. So now let's work together starting from here. So if I have inner product of norm squared of x minus y, so I have x minus y comma x minus y, right? Then I'll start to open just like I did here. Then here I'll have x comma x, don't forget you have minus here, x comma y, then minus, open this, y comma x, right? Then minus times minus turns to a plus, so here I have y comma y. Then here this is the same thing as norm of what? Norm squared of x minus x comma y minus y comma x, then plus what? Norm of y. So I can automatically call this equation what? 2. So like I already have this man here and this woman here, so I can like merge them together, right? So I'll say subtracting equation 2 from 1, 2 from 1. So if I should subtract 2 from 1, all I have, so I'll have this minus this. So let me just write it out. So I have num squared plus inner product of x comma y plus y comma x plus num of y, right? Then minus whatever I have here. So I'm done with the first one, so minus everything I have in the second part. For the second part I have this, so minus times minus turns to what? Plus inner product of x comma y plus inner product of y comma x, then minus num of what? Y. So let me just do this. So notice that this and this will go away, this and this will subtract. Similarly, this and this will go. So I have this, 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 and this left. So this and this are the same. So I'll say this automatically. I'll have 2 x comma y plus 2 y comma x, which is equal to just this first two. So that's x plus y squared minus x minus y squared. So equation asterisk. So we have this. Now let's go to the complex part. So I'm going to the complex part. I'll have to start with the first one, right? So the first one, I have this. Okay, so I have x plus I y squared. So if I want to do this, what will I do? I'll just have to like open, right? So it's going to be equal to x plus I y comma x. So what you just have to do is go to the second one since we're done with the first one. So I'll have x comma x plus I y, then use I y comma x plus I y, then x comma x, x comma I y. Same here, iy comma x, then iy comma iy. Can you see? So then this is the same thing as num squared of x. This is x comma iy comma x, and this is num squared of iy. Then I have this. So what I just have to explain here is you have here to be real and here to be complex. If I'm taking my i's out, this is going to be I complex, conjugate. So I conjugate is going to be minus I, because I have minus I here. So but here I'm not going to have minus I because I'm bringing my I from this side. So I just have I, then y comma x plus I modulus of I squared, then num squared of y. So to continue, sorry for the solution. So here I'll have I y comma x plus, this is going to be equal to 1. How? Because normally what is I equals what? I squared equals minus 1. So I equals square root of what? Minus 1. So we are looking for absolute value. So this is equal to square root of 1, and if you're having the square, so it's equal to what? 1. So definitely automatically here you have this to be 1. So here I just have y, num of y all squared. So then we can then multiply by this I. See, I told you I was taking it step by step. We did this already, this, then we're going to this. So we have to like multiply by I. So now let's do that. So multiply by I here. So you have I multiplied by x plus iy squared. So I'll have it to be, so this is going to be I x squared. I times I here will have what? Minus I squared x comma y plus I squared y comma x plus I norm squared of what? Y. Then here I'm going to have it to be I norm of x squared. So my if I have I squared, it is what? Minus 1. So but don't forget I have minus here again, so minus times minus will give us plus. So here I'll have plus 1, so plus x comma y. But here automatically, because I squared is minus 1, so I'll have minus y comma x plus I norm squared of y. So let me call this equation 3. So we have equation 3 already. Now we'll have to go to equation 4. That means like we have to solve this man here. Now we're done with this and this. So now we want to do this. So after doing this, then we'll sum all the equations together, and if we have this, then our proof is correct. And so let's go. Yep. Happy. So this part now. So I have norm of x minus I y all squared, which is going to be equal to the way I explained in the beginning. Yeah, don't forget. So x minus I y comma x minus I y, right, inner product. So start the way I explained, opening the brackets. So you have x, not brackets per se, but you know that's like the best way to explain. So it's going to be x comma everything here, x minus I y minus I y comma x minus I y. So here I'm going to have x comma x, this times this, then minus, because you have minus here, x comma I y minus this I y comma x, right? Then minus times minus turn towards plus I y comma I y, right? So what we just have to do is take it step by step now. So this is norm squared of x, right? Then minus, don't forget, if I'm bringing this I out, what's going to happen is going to be minus I, conjugate of I. So if I have minus I, automatically here I have what? Plus, right? Like I explained in the previous video. So it will be x, sorry, not previous video, previous explanation. So this is going to be minus, if I bring this I out, it's not going to be conjugate, so it's just going to be minus I. So this is y comma x plus norm squared of this, right? And this is going to be x squared plus I x comma y minus I y comma x, right? So if I, like we did here, so here automatically I said when you have I, absolute value of I squared, it's going to give us what? 1, right? So square root of 1 is 1. So here I'll just have norm squared of y. So don't forget, we're done with this, but we have to multiply by what? I. Multiply by, we're done with this, so we have to only multiply by I. That's what we have to do left now. So I'll have I x minus I y to be equal to, this is my x minus I y, norm of it. So I'll just have I norm squared of x plus I times I will be what? I squared x comma y. I times I minus I squared y comma x plus I y norm of y squared. So here I just have I x squared, right, minus, because I squared is minus 1, right? So x comma y. I hope you're enjoying the way I'm explaining. If you do understand how I'm explaining and then you enjoy how well I'm explaining, please just subscribe to my channel and like my videos. I promise to upload more interesting and educating videos in mathematics and other aspects. So here I squared is minus 1, so minus 1 times minus here to be what? Plus. So I have y comma x plus I norm of y all squared. So this is my equation what? Let's see. So equation what? 4. So we have equation 1, equation 2, equation 3, and now equation 4, which are all this here. Equation 1, equation 2, equation 3, and equation 4. So when I have all these equations, I'll just have to like put them one by one here and subtract when necessary, add when necessary here. So let's start. So for the first one, this x plus y all squared, I think we've done this first two already. So we did this and we named this equation asterisk. So let's just write asterisk out now. So I'm writing asterisk out this. So it's going to be, so I'll have, so let me do this so it's going to be easy. So now, you know, we're working with left hand side, and this is what we have in the left hand side. X plus y squared minus x minus y squared plus I, x plus iy. So this is going to be equal to, so now this is what we're solving. So we already have this to be equation asterisk. So now let's just write out equation asterisk, and equation asterisk is this. So we have 2x comma y plus 2y comma x. Now remaining this, so this is equation 3. So this is equation 3. And where's my equation 3? Everything here. So I have plus I norm of x squared plus x comma y minus y comma x plus I norm squared. So minus everything here. And what is this? Equation 4, right? So what's my equation for this? So you know what, subtracting minus, so minus will affect everything here. So I have minus I minus and minus plus x comma y minus y comma x minus I. So this is going to be equal to, notice that this and this will go away, this and this will also go away. So x comma y, inner product of x comma y and x comma y, so let me mark this, they stay. So I'll have 2x comma y, then this will be what, minus 2y comma x, then don't forget our main man here, so plus 2x comma y plus 2y comma x. So this is going to be equal to, this is going to go, this and this will go, so we're left with 2 plus 2. I have 4x comma y, but don't forget we're multiplying by what, 1 over 4, so everything into 1 over 4, which is going to give us what, x comma y. Balam! This is what we're looking for. We said if we're able to prove from left to right, which is our, from right to left, so this is equal to what, left hand side, then which it implies that what, our proof is correct and valid. So thank you for watching this video. If you do understand what I just explained, please yes, please do subscribe to my channel and turn on your notification bell, because trust me, I'll be uploading more interesting videos, explanatory videos for you to understand. Thank you very much for watching this video. We're able to prove from right to left, and we have our proof. Thank you. Polarization identity. All right, thank you, and have a nice day.